The engine spins constantly when it's running. Even at idle, the crankshaft rotates about 800 times per minute. Your wheels, however, need to start from zero and change speeds constantly. This creates a problem. How do you connect something that never stops spinning to something that needs to start and stop smoothly? The clutch solves this by acting as a controllable connection between your engine and transmission. When engaged, it locks these two systems together so they spin as one unit. When disengaged, it completely separates them, allowing the engine to run while the wheel stays still. The clutch system consists of several key components working together. At the heart of the system is the flywheel, also known as the driver plate, which bolts directly to your engine's crankshaft and spins with it constantly. This heavy metal disc stores rotational energy and provides a smooth surface for the clutch to grab onto. The clutch plate, also called the driven plate, sits between the flywheel and the pressure plate. This plate has friction material on both sides, similar to brake pads, but designed to handle the heat and pressure of constant engagement. The friction faces are mounted on cushion springs, which compress during engagement, allowing for smoother starts and torque transfer. The center of the clutch plate connects to the transmission input shaft through a splined clutch hub that allows it to slide along the shaft but forces it to rotate together with the shaft. The clutch plate and the splined hub are connected through damper springs which absorb the shock and vibrations when the flywheel and clutch plates engage, preventing jarring movements. The clutch cover assembly is bolted to the flywheel and houses the pressure plate. The pressure plate is mounted within the clutch cover using drive straps and serves to clamp the clutch plate between itself and the flywheel. This assembly contains a diaphragm spring that resembles a cone made of metal. When the clutch pedal is not pressed, this spring pushes the pressure plate against the clutch plate, which presses against the flywheel, creating friction that locks all three components together. Two wire rings within the clutch cover support and position the diaphragm spring. The release bearing pushes against the center of the diaphragm spring when you press the clutch pedal, initiating the disengagement process. In the engaged state, when the clutch pedal is not pressed, the diaphragm spring pushes the pressure plate toward the flywheel with tremendous force, often exceeding 2,000 pounds. The clutch plate gets squeezed between these two spinning surfaces with enough pressure to handle hundreds of foot-pounds of torque without slipping. The friction material on the clutch plate grabs both the flywheel and pressure plate surfaces. Since the flywheel spins with the engine and the clutch plate connects to the transmission, this friction coupling transfers all the engine's power to the wheels. The three components now rotate as a single unit. When you press the clutch pedal, hydraulic forces pushes the release bearing against the center of the diaphragm spring. The diaphragm spring acts like a lever. Pushing on the center causes the outer edge to move in the opposite direction. This motion only needs to move the pressure plate a few millimeters, but that's enough to completely separate the clutch plate from the flywheel. With the pressure plate pulled back, the clutch plate floats freely between the flywheel and pressure plate. The engine can now spin the flywheel independently while the transmission input shaft and clutch plates remain stationary. You successfully disconnected the engine from the transmission. The release bearing only contacts the diaphragm spring when you press the clutch pedal. When engaged, the bearing allows the pressing surface and the diaphragm spring to rotate together while the release bearing holder remains stationary. Most modern clutches use hydraulic actuation systems to multiply the force from your foot and transfer it to the release bearing. The hydraulic actuation system consists of the clutch pedal, clutch master cylinder, fluid reservoir, hydraulic lines, clutch slave cylinder, fulcrum point, release fork, and the release bearing. When you press the clutch pedal, it pushes a piston inside the master cylinder. This piston forces fluid through the hydraulic lines to the slave cylinder. The slave cylinder contains another piston that's larger than the one in the master cylinder. Since hydraulic pressure remains equal throughout the system, the larger piston moves with more force but travels less distance. The mechanical advantage means a 20-pound push on your pedal can create 200 pounds of force at the release bearing. The hydraulic fluid cannot compress, so every millimeter you push the pedal translates directly to proportional movements at the slave cylinder. This direct connection gives you precise control over clutch engagement. When fluid pressure builds in the system, the piston inside the slave cylinder pushes against the release fork. The release fork pivots on its fulcrum point and moves the release bearing forward, which presses the diaphragm spring inward. In response, the outer edge of the diaphragm spring pulls the pressure plates backwards, releasing the clutch and separating the engine from the transmission. This is how a clutch works. The next time you press a clutch pedal, remember the sophisticated engineering beneath your feet. If you enjoyed this video and would like to support our small channel, please subscribe and hit the notification button. Thank you for watching.